Okay, class, today we're going to be beginning our unit on speed, velocity, and acceleration. So we're going to begin physics. Before you view this video, you want to have a sheet of paper out. You should have it set up to do some Cornell notes. And the PowerPoint that this slideshow or this flip chart is based on is loaded to the class jump if you need that to help you. So our objective, we will contrast or tell the differences between speed, velocity, and acceleration. We'll do this two ways. First, we'll be solving word problems this week where we're calculating speed, velocity, and acceleration. And second, we'll be investigating the motion of objects while calculating their speed, velocity, and acceleration. Let's begin with the idea of motion. When an object changes its position, motion has occurred. There's two topics related to motion. There's distance, which is simply how far an object has moved, and displacement, which is how far an object has moved in relation to its starting point. So you have to consider the direction. Our example here, two runners travel along the same straight path in a straight line for 500 meters. At the end of their run, their distances are the same, but their displacements are different. How can this be so? I'd like for you to answer in your Cornell notes how these runners could have the same distance but different displacements, and we'll talk about this Monday before our lab. Speed. Speed is the distance an object travels per unit of time. So the relationship between speed, distance, and time is the formula for calculating speed, which is distance divided by time. You can have constant speed, which means speed does not change over time. You can have average speed, which is the speed of motion when speed is changing. Basically, you take the total distance traveled divided by the total amount of time that it takes to travel that distance, and that's your average speed. And then instantaneous speed, which is speed at a given moment in time. So that's like if your parents are driving, they look down at their speedometer at that moment, what their speedometer reads is what their speed is. There we go. Graphing motion. Guys, to graph motion, you always want to use a line graph, which shows us a change in distance over time. Distance would go on the y-axis, time on the x, and you can calculate speed with a line graph by calculating the slope of the line, since rise over run is the same as distance over time when graphing speed or distance and time. You can have a couple of different graphs for distance and time. You can have something that looks like this, where it's a straight horizontal line. That indicates the distance is not changing, but time is going on. When this happens, you have an object that's not moving. Okay, time is passing, the object is staying still. Or you might have something like this, where you have a gentle slope at the beginning, and then the slope gets very steep. That indicates that during this gentle slope, the object was slow or moving, starting out pretty slow, and then it speeds up. And when it speeds up, you have more of a slope to your line. So what I like for you to do is this graph here shows three different sections of a distance and time graph. You have stage 1. The object is moving 100 meters in 10 seconds. Stage 2, it's moving 50 meters in 10 seconds. And then stage 3, it's moving 150 meters in 20 seconds. I'd like for you to pause this video and calculate the speed at each section. So for stage 1, 2, and 3, the average speed overall, and the total distance that the object moved. So in stage 1, you have 100 meters in 10 seconds, which means its speed was 10 meters per second. In stage 2, you take distance, which is 50 meters, divided by time in 10 seconds, and you have 5 meters per second. And then stage 3, the object traveled 150 meters in 20 seconds, so its speed was 7.5 meters per second. The average speed of the object, you have to take the total distance divided by the total time, and it would be 300 meters divided by 40 seconds, so the average speed is 7.5 meters per second, and the total distance traveled is 300 meters. Velocity. Velocity and speed are related in that they both use a distance divided by time formula. However, velocity also tells us the direction the object is moving. So 88 kilometers per hour is speed, but 88 kilometers per hour southwest is velocity. Acceleration is a change to velocity or speed. An object can increase speed, decrease speed, or change the direction that it's moving, and all of those are considered acceleration. The formula is final velocity minus initial velocity divided by time. It is measured in meters per second squared. So I have a practice problem here. A roller coaster has a velocity of 100 meters per second at the top of a hill. 2 seconds later, it reaches the bottom of the hill with a velocity of 20 meters per second. What is the acceleration of the roller coaster? Please pause this video, apply your formula, and solve this word problem. So what you do is you take your final velocity, which is 20 meters per second, minus your initial velocity, which is 10 meters per second, divided by 2 seconds, and your answer is 5 meters per second squared. That's the end of speed, velocity, and acceleration. What you want to do now is make sure you have your Cornell notes finished. Rewatch the video if you need to. Make sure you have essential questions and your summary. And I will be checking on Monday that you have your essential questions, summary, and any of these word problems solved in the Cornell notes. Remember, the PowerPoint on Class Jump can help you finish your Cornell notes if you need them. Okay, have a great weekend.